Okay. Hello. I'm so glad you could make it. Just a quick thing. If you are tuning in live, if you could write your name and the school that you're from in the chat, that way we know who's showing up. And then we'll get started. So, thank you so much for showing up. I'm so glad you're here. And let me know. Feel free to always ask questions. I can see the chat section, so I can always be reading that as we go. And again, ask questions if you don't know what something means, want some more clarification, anything like that, feel free to ask. And if the audio or visual or anything messes up, also please let me know so I can fix it. So, today we will be coming... Okay. Hi, Maddie. So glad you're here. And definitely tell your friends about this because we're going to be doing this every Friday. So love to have you and anybody who wants to watch. So today what we'll be doing is we'll be going over some of my favorite chemistry reactions. I went to school to become a chemist, so it really is something special to me. I really, really enjoy it. So we're going to go over just a couple of my favorite reactions, and I think you'll see why they're some of my favorite. So just to start off, what we're working with for these first three solutions, and you should see those three solutions on the close-up screen there, is this chemical called lead nitrate. Now, lead is it's a heavy metal. It's really, really dense, and it's poisonous. So I have to be really careful. That's why it's wrapped up in this, and that's why I'm wearing gloves today. But it does some really cool stuff. So what we're going to be doing is we're going to be mixing it with an acid, which we talked about last week. It has a low pH. We'll be mixing it with a base, which has a high pH. And then we'll be mixing it with something completely different called potassium iodide. And potassium iodide is normally a crystal. It's a powder, and that's what's in here. But I mixed it up with some water, and it's going to do some really cool stuff. So let me make sure we can see everything here. So we're going to start off with the acid and the base. So what's going to happen is something really cool is going to happen. So it is hydrochloric acid. Great question. And the base is sodium hydroxide. So hydrochloric acid is HCl, which is a hydrogen and chlorine. And then sodium hydroxide is sodium, which is Na. And then hydroxide, which is OH, which is an oxygen and a hydrogen. So those are great questions. So I'm going to take just a little bit, and this is pretty concentrated, so we're not going to need a lot. And we're going to drop this in. In fact, I think we're going to do it like this. So this is a clear solution. We're mixing with a clear solution, right? So then when we mix them together, we get this white precipitate. And a precipitate is really just a fancy scientific term for we made a solid. See, now it looks like milk. So now it's this solid white mixture. Because we made something new, and that's what chemistry is. So chemistry is when we take two things or more and combine them together, and then they react with each other to make something brand new. So now what we're going to do is so that was the base. So now I have another solution. It's the lead nitrate again, and we're going to mix it with just a little bit of acid. Again, this is pretty concentrated, so we don't need a lot. And I'm using a different pipette because we don't want contamination. Because when you mix an acid and a base, you create water. So then, when we add the acid to this, it does the exact same thing color-wise, but it's actually creating, see, if you can see, it actually didn't stay suspended in solution as long. So what we're going to do is we're going to add a little bit more. And when I say suspended in solution, I mean floating around. So we can see all those that white powder is now floating around. And again, I'll do it really up close so you can kind of see it swirling. So I think that looks really cool. And then down in there. And because it's what's called a precipitate or a solid, it is really heavy. And it falls out of the solution and it becomes this snow-looking stuff. And it doesn't stay floating. It just sinks right to the bottom. And you can see here's our other one. It's just cloudy. So it went back to kind of clear. So those are two white precipitates that came both from lead. So what happened was the lead met either the acid or the base, and it combined with those to make something new, and that new thing could no longer dissolve in water. And since it can't dissolve in water, it falls to the bottom as a solid. So now what we get to do is my real favorite. I'm going to set these off to the side a little bit, is this one. So again, this is still that lead nitrate. We're a clear solution. And I'll start off with the dropper for this. And now we're mixing it with potassium iodide, which again is also clear. And when we add this, we create a bright yellow precipitate. So two clear liquids combine to make this bright, bright yellow. And this one, it's the same thing. We created something brand new from those chemicals. We combined those chemicals and we made something new that didn't exist before we combined them. And now that new thing also doesn't dissolve in water, but it also is bright yellow. So since it's not dissolving in water, it falls out and it's really colorful. So we make this really bright yellow gold precipitate to make our new compound. And that, again, that's from lead. So I'm going to set these off to the side for now. If we have some extra time, there's another really cool thing we can do with this gold one. But it takes a little bit of time. So we'll have to see where we're at. Why does it change yellow and not white? Because it made something different. So these two white ones, the acid and the base, I believe it made a lead mixed with a nitrogen and a hydrogen, or an oxygen and a hydrogen. And then this one, the potassium iodide and the lead nitrate, it made lead iodide. And that is what the lead iodide is, what is bright yellow. So we just made different things with different mixtures of starting stuff. That's a great question, though. Keep them coming. So now, what we're going to do is we're going to get into the follow along section. And this is going to be what's called an iodine clock. So I didn't prep anything in advance because I wanted to show how I do the preparation. So I'm going to just wipe off my table and then hopefully we'll be able to see everything. So an iodine clock is really cool. So the reason it's called a clock is because the chemical reaction that will be taking place, it's actually 3 chemical reactions. So what we're going to be doing is we're going to be combining vitamin C with iodine. And this is the regular iodine that you might get at the store just to clean your wounds Doctors use it before surgery. It helps sterilize areas. So it's found in the medical section next to like the hydrogen peroxide and the rubbing alcohol and stuff like that. So when you combine vitamin C and iodine, the iodine turns into iodide. I know that sounds really close. One's iodine ends with an N, and then one's iodide ends with a D, or an NE versus a DE. So the iodide, the one we're going to make when we combine these two things, is clear. It's colorless. But the iodine, you can see, is this dark brown color. So we're going to combine those two things to make a clear solution. And then we're going to take some starch. This is liquid starch used for laundry, but you can use any kind of starch. And like cornstarch or potato starch, it really doesn't matter. All you have to do is dissolve that in water a little bit. If you're using a solid starch versus this liquid. And then we're going to mix that with hydrogen peroxide. And those don't actually react, but the reaction will happen later on. Why vitamin C and not any others? That's a great question. I'm not sure if other vitamins do this, but vitamins have a really complicated chemical structure with a lot of branching arms and stuff like that. So it must be the way vitamin C specifically interacts with iodine, and vitamin C is super easy and cheap to buy at the store. So maybe there are some other vitamins that do that same thing, but they're more expensive, so the ingredients that we chose are because they're easy to get. So usually, one thing that we have to do, and actually I forgot to grab this, so we're going to need a coffee filter as well. Because vitamin C tablets are not just vitamin C. There's a whole bunch of other stuff in there that we don't care about. So our first step is going to be making our vitamin C solution, and we actually only need a very small amount. So we're going to take one tablet, and on some kind of either a piece of paper or aluminum foil, and I realize I left mine over here, so I'm just going to grab mine really quick. Oh, there they are. I'm going to use this fancy thing called a weigh boat, but you can use anything, just some aluminum foil or something like that, whatever you have around. And then a spoon works best, because we're going to be crushing this up. So, I'm going to angle this so you can maybe see it a little bit better. Okay. So we're going to take our spoon and just like really crunch this up. No! My camera! My close-up cam. Okay. We want to try to get as many of the chunks as possible. And then once we have that, now we're going to mix that with some water. And we're going to mix one tablet with about 2 ounces of water. And you can use your best judgment here. And here, I forgot to mention, it's really important, if you can get it, to use distilled water, because that is going to work a whole lot better than just your regular tap water, because your regular tap water has a lot of stuff in it. And that stuff, the calciums and the different minerals and stuff like that, can interfere with our chemical reaction. So, I'm going to stir this up, and I maybe added a little bit more, but I added 50 milliliters of water. So I'm just going to stir this up until most of it's dissolved. Now, you can see it's kind of cloudy, and that's the other stuff. So there's some stuff in vitamins, tablets. When you eat them, there's stuff that is not very water soluble, which means it won't dissolve in water very well. But that's why we have this coffee filter, is we're going to just filter off that stuff that we don't need. So I'm going to, and this is kind of what it looks like. You can see there's still some stuff at the bottom. That's okay. Because now what we're going to do, we'll set that to the side. We're going to take our coffee filter and we're going to fold it into this little pizza shape. And then we're going to open it up. So one side has 3 of our sides. 1, 2, 3. And one side has 1. But we make this nice little cone. And then once we have that nice little cone, we're going to put it into a bigger container and fold it down just a little bit. So we can see we're going to fold that down. And then we're going to just slowly pour in our vitamin C solution. And any of those solids that are in there are going to get trapped on our coffee filter, which is good because we don't want those. We just want what dissolved in water, which is mostly just vitamin C. So sometimes this can go a little slow. That's okay. And just so you can see what this looks like real deep down. Hopefully that kind of shows it. So it's just going and going and going. We have to wait a little bit for it to drain and drip, and then we just keep topping it off. And the more stuff it collects, more of those solids. And you can see there's what we have left behind. We can just set that aside. We don't need those solids. And then once we have this, you can see there's still some liquid in here. So now what I'm going to do is I'm just going to go put this wet coffee filter over in that waste because we don't need that anymore. And now you can see it's kind of yellowish, but it's mostly clear. It's not so cloudy anymore. So there's our vitamin C solution. So that's just our first solution. So now what we need to do is we need to combine that vitamin C with some water. So we're going to make, that's just our first starting thing. So that's just a vitamin C. And now what we're going to do is we're going to take just a little bit of that. We don't need a lot. I'm going to use a pipetter, but you can just pour this. And I'm going to take about 2 milliliters, and I'll show you what that looks like. So here's our 2 milliliters. It's not a lot. It's enough to basically cover the bottom of my container. So not a lot. And then, so that's all the vitamin C that we needed. And then what we're going to do is we're going to take a little bit more water. And we're going to bring it up to about 40 milliliters. Or sorry, yeah, 40 milliliters. No, 60. I lied. Reading is hard sometimes. Even for scientists. So now you can see we've diluted that a whole bunch. It looks pretty clear. There's no chunks or anything. And now what we can do is we can take our iodine. And these usually come with kind of a squirt bottle top. So we're just going to add a few squirts of this. So you can see it starts off kind of brown and colored. And then if we give it some time, I'll do it that one more time just so you can see it again. Hopefully I didn't add too much. It goes away. So what's going on is, remember that vitamin C reacts with iodine and creates iodide. And that iodide is soluble or can dissolve in water. So it changes it to something new through chemistry, and then that something new is water soluble, and it disappears into the water instead of being able to actually see it. So now, this is our solution A that some recipes call for. So it's vitamin C, water. So we took a little bit of our vitamin C solution, we added water and iodine, and we have this clear liquid now. And now we need to make our second solution. So that second solution is hydrogen peroxide, and this is the 3% medicine hydrogen peroxide that you get at the grocery store in the medicine section. And we're going to take about the same volume. I can't do 60, but what I can do is about 50 milliliters. I'm going to go a little bit less than 50 milliliters. So hydrogen peroxide, right, when it touches it's used for a lot for cleaning out wounds. If you ever get like a cut, you can put some hydrogen peroxide on there and it starts to bubble. And those bubbles are oxygen. So hydrogen peroxide, the chemical formula for that is H2O2, which might sound familiar because water is H2O. So hydrogen peroxide is just water with an extra oxygen molecule attached to it. So those bubbles that you might see when you put it on a wound or organic material like that, it reacts with that and releases those extra oxygens and puts it into the air as bubbles of oxygen. So all we have right now is that, and we're going to add a little bit of starch. And I'm going to use liquid starch. If you're using a solid starch, you would do kind of the same thing you did with the vitamin C, where you mix it all together. You might want to heat it up because some starch doesn't dissolve well in water. And then you want to filter that as well so it's not too cloudy. So again, I'm just going to take, we don't need a lot, but I'm just going to take, actually I don't even need that much, like this. You can see it's kind of cloudy. And I'll do this in the close-up cam so you can see this better. So clear hydrogen peroxide mixed with a few drops, maybe 10 to 15 drops of starch. And the reason we're doing this, I'll explain in just a second. So I'm going to stir this with my spoon. Oh, no, I need a new spoon. So we're going to just stir this up a little bit, combine those. And it's a little cloudy, but it's still mostly clear. If you wanted to show this off to your friends and wanted to use less starch, you could totally do that and it would still work just fine. So now we have these two solutions that are mostly clear or, at least not colorful, right? And now we get to do the fun part. So we're going to mix these two together. And if you remember, we really have four things here. We have hydrogen peroxide. We have iodide or iodine. We start with iodine. It turned to iodide. We have vitamin C. And we have starch. So some things to know before we start is starch and iodine, when you mix those two together, it creates this dark blue. So it starts purple, or sorry, not purple. It starts this brown color. And if you mix this with a starch, it will turn blue or black. And that's actually, it's used as a way to test for starches in different foods and stuff like that, is if you combine it with iodine, it'll turn blue or black. And then you know that, hey, there's starch in this. So another thing to know is that vitamin C mixing with iodide to make iodide, the vitamin C can be broken down by mixing with hydrogen peroxide. So if we break away all of that vitamin C, that iodine will come back, the iodide will turn back into iodine because the vitamin C goes away and it goes back to where it started. So when we mix these together, we should see that the iodide will go back to iodine, And if there's iodine and starch around, it should turn blue or black. Now, the reason this is called an iodine clock, so I'm going to mix these two together. And then we're just going to watch this. We'll give it a good swirl. So the reason this is called an iodine clock is because depending on how much of each stuff you used, it will take different amounts of time for this chemical reaction to happen. So you can see there's nothing happening, right? It's still clear. But if we give it enough time, right now that hydrogen peroxide is eating away at that vitamin C, and it has to eat away at a bunch of it before that reaction will happen. So we're just waiting for this reaction to happen. And what we can do is we can play around with how much stuff we added in order to make this reaction go faster. So we can see, I can already tell, I don't like how slow this is going. So what we're going to do is we're going to mix a new one, but this time with a lot less vitamin C. And we're going to wait for this one to, we won't pause this. We'll let that one keep going. But while we wait for that one, I'm going to start making a new one. So this one has way less vitamin C. Can you add more hydrogen to make it faster? Yes, that is a great call, and we definitely could. In fact, let's test that, right? So we don't know how long this is going to take, but you're right, adding hydrogen peroxide will speed up this process. And you know what another factor of this is? Yeah, or add less vitamin C, exactly. Oh, there it goes. So you can see we added more hydrogen peroxide, and bam, it went. So what we're going to do, and I'm glad you're here too, and I don't know who you are, but if you could say your name and the school you're from, that way I can report that stuff. But you can see this is two clear solutions, and I'm going to do a close-up on our bigger camera. You can see this is dark black, right? So now we're going to do the same thing. So we have only a small amount of vitamin C in here. And we're going to add some iodine. And because we have less vitamin C, it's going to take a little bit longer. Oh, but there it goes. The iodine's disappearing. So once we have that, and now we're going to make another starch solution, which again was hydrogen peroxide. I'm counting percent of light it blocks out. That's a great question. I don't know the percent of light it blocks out, but because that takes special instruments to figure out. But what we can do here, what I'll do is I can turn my camera, and we're going to hold this up to the sunlight. So, here's our kind of cloudy vitamin C. And then here is our, we'll let the camera focus. So I'm not really seeing any light get through. Maybe if we get really close. Sorry, focusing. Here. Yeah, I'm not really seeing anything on it. Great questions, though. Okay, I'm going to move us back here. Yeah, it's not letting much light through at all. So we're going to create another hydrogen peroxide and starch solution. And I have more hydrogen peroxide, so it's okay if we're out. And maybe I'll add a little bit less starch this time. And it will be a little bit less dark. but the reaction will still happen. Great questions, though. Awesome. Thank you, Emily. And what about you, Kat? If you, or I am a cat, if you could put your name and the school you're from, because we, as a flagship program, we're taking attendance, basically. Okay, so now I'm gonna mix this up. This is our hydrogen peroxide and starch, and then this time we have a. Oh no! What is that? Oh, some foil from our starch container, I think. Awesome. Thank you, Zeb. Okay. So now I'm going to go dump this. And this is all super safe, so I'm just going to dump it down my sink. Okay, hopefully we've got most of that stuff out. So now what we're going to do is we can combine this, and this time it's going to have a lot less vitamin C. In fact, I'm going to add all of one and then all of another. Here we go. Give it one good swirl, and then we'll just let it go. And hopefully this is enough this time. There it goes. It's changing already. So, since I added less starch, it didn't get as dark, right? And I'll do another close-up just for a comparison on the bigger camera. So not as dark. It's more of like this pinkish color. Purple. So what we can do to get it back to that really dark color is just add more starch, because that's what that iodine mixes with. So if we just add more starch. Oh, you know what? It wasn't the starch. We had plenty of starch. What we didn't have enough of is the iodine. So now see, this is what science is, right? We have to keep testing things until we get it just right. It's pink, yeah, like a purple, exactly. So what we can do is we can do this one more time, and this time we know exactly what was going on. And we know how to fix it. Because that's what science is all about, right? We test one thing, and we only change one thing at a time. So now this time, we're going to add that same small amount of vitamin C. And I'm going to need to go grab more peroxide. Oh, actually, let's try this one. So this one, I'm a little afraid to open it because it has, I don't know if you can tell, it's kind of bulging. It's like about to pop. So if I explode, you'll know why, and you'll get to watch it live. Oh, that was anticlimactic. Man, I wanted that to like really pop. Oh no. See, we're okay. We made it out. Okay. But this is a fresh bottle. So the peroxide goes in this one. This is our starch one. And then, who can remind me, what do we need to put in our vitamin C one? Besides just water. It's the thing we were missing last time. Iodine, good. Yep. So the hydrogen peroxide one gets starch, and remember, we don't need a lot, because we found out last time that was not our limiting thing. You were really close. It's I-O-D, and then you had it. Iodine. Okay, so now we need to make sure we have enough iodine to react with the starch. And what can kind of happen sometimes is we'll find out that this much iodine wasn't enough to get rid of that color and turn it all to iodide. So we just need to add a little bit more vitamin C if that's the case. So we'll give this a second, but I'm thinking we need a little bit more vitamin C. Which means it'll go a little bit slower, but we'll have enough iodine. Man, I must have added a lot. We might have to redo this whole solution. Because remember, we don't want too much vitamin C, otherwise it takes too long. So what I'm going to do is I'm just going to dump out half of this, and then we're going to fill it back up with water. Then we're going to add a small amount more vitamin C. I know, it's kind of a fun sound, isn't it? Yeah, there we go. Okay, cool. So now, this time, if we've done all our measurements correctly, what we should see is when we mix these two together, it should react fairly quickly, and it should turn black now. So we'll give it one good swirl, and then let it do its thing. Yeah, there we go. We did it. Sweet. So, one place you might see this as a magic trick, and because a lot of magic is really just science that people don't explain. So we've been doing magic all day, right? We've been turning clear stuff into not clear stuff, which might be magic if we didn't explain it. But since we explain it, it's science. So, it's looking like we have a little bit extra time. So what we might do is come back to we have another experiment that we maybe can do. And I'm a little scared of my kitchen or my living room because it's messy. But it's not real science unless you're making a mess. So before we move on, does anybody have any questions about this? And while you ask those questions, I'm going to start cleaning up just a smidge. So since we have a little bit of extra time, we're going to do another one of my favorite chemical reactions. And that is something you may have heard of. It's called elephant toothpaste. So elephant toothpaste is using hydrogen peroxide, but for the really fun, fancy one, we're not going to use the 3%. Because the 3% just isn't strong enough. We're going to use 30%. So this is kind of old, so because it's old, it might have dissolved. Yes, Mark Rober did do this. He filled a swimming pool full of this stuff. Hydrogen peroxide at really high percentages, which is 30 to 35% is your max, it starts to degrade over time. So this is somewhere, but because this is a little bit older, it's somewhere between like 30 and or 20 and 30%. So we're not exactly sure. But the reason this is one of my favorite chemical reactions is because we get to use this really cool stuff called potassium iodide. So, if you remember, in our last experiment, the Iodine Clock, we turned iodine into iodide. Well, this time, we're starting with iodide, right? It's just mixed with potassium. So we're going to combine this as just solid crystals. We're going to mix it with our water. And we want what's called a supersaturated solution, which means we want more of this dissolved in our water than is allowed. Because the more that we dissolve, the more the reaction goes. So when I say is allowed, I mean is allowed at the temperature that it is without any outside influence. So if you think about water, right? Or sorry, if you think about salt, when you heat up some water, you can actually dissolve more salt, or sugar is another really good example. If you heat up water, you can dissolve more salt or sugar in that water than you normally would be able to. So that is normally would be able to at the temperature, at room temperature. So if we heat it up and then cool it down, so all of those crystals have now dissolved. So because of that, we're going to add a little bit more, because we want it to not be able to dissolve any more crystals. Again, if you're not making a mess, are you even really doing science? So now we can see there's more crystals in here, and we're going to try to dissolve those. Sometimes it takes a little bit to do that, though. So we're going to and you can't feel this, but this is cold. So because it's cold, it's what's called an endothermic reaction. And endo means in, and thermic means energy or heat. So this means that it's drawing heat into itself, which makes it feel cold. So it's taking my heat, or the heat in the air, and drawing it in. The opposite of that is an exothermic reaction, which means heat out. Exo means out, and then thermic, again, is the same thing as energy or heat. So that means it's putting off its own heat, and it's going to feel hot. So that's mostly dissolved, which is good, but we can't seem to get those last little bit of crystals, which means we can't dissolve any more in this water. So now what we're going to do is we're going to take our hydrogen peroxide, and I'm going to do a mini test first. So if we take this hydrogen peroxide and combine it with a little bit of our potassium iodide, watch what happens. So it's putting off a whole bunch of steam. Woo! And it released all of that oxygen, really that was bound, because remember, hydrogen peroxide has extra oxygen compared to water. So it released all of that oxygen really fast, because this Ki, potassium iodide, is a catalyst. So because it's and now this is very hot. You can see it steaming. So what we're going to do now, you saw it release all of that stuff. What we're going to do now is we're going to add a little bit of soap, and this soap, and oh, not my camera. Okay, hopefully. This soap is going to trap. I really should have like a tarp laid down for this. I wasn't planning on doing this today, but we have extra time, so let's make a mess. So now we have that soap, and I'm gonna go grab my colors. Here they are. So what color do we want this to be? So again, remember, because we're releasing this soap, because we generated so many bubbles, this soap is going to trap all of that oxygen and make a bunch of bubbles really quickly. Orange, we can totally do orange. We'll do 4 drops of yellow, 3 drops of... we'll do 2 drops of red. See how that turns out. Yeah, that's a reddish orange. That's good. So now I have to do a test. Okay. So I didn't know what was left over, because what was left over in this was either, if all of the potassium iodide was used up in that first test we did, then that would mean there's leftover hydrogen peroxide. If there was leftover hydrogen peroxide, that means all the potassium iodide was used up. And I should have tested that first. But now, let's make some space. Can we all see this? And you know what? I'm going to tilt our big camera down just a smidge so you can see this. A little bit better. You might cut off the top of my head, but that's okay. We're here for the science, not for me. Okay. So now, and I have to do this kind of smaller than I normally would because we're in my living room. So it creates, and you can see this, I don't know if you can see it, but there's a bunch of steam coming up. Really messy and hot, yeah. So we can do a little bit more. And it's just going to keep creating this foam until all that potassium iodide is used up. So now, maybe we switch back to potassium iodide. Maybe we have... Yeah. There we go. So we're creating even more foam and steam. So much so I don't know where the top of this is to add more stuff. There it is. There's that big gust of steam. Oh, that close-up camera looks really good. At this point, I'm just guessing. So all of that steam is because it's an exothermic reaction. And that means it's producing its own energy. And it creates all this foam and really hot steam. And remember, that's just the oxygen. That is released from the hydrogen peroxide getting released into that soap, and that soap traps it all. So, because we're good scientists and we're wearing proper gloves to keep us safe, we can actually touch this, and it's this really goopy foam. But it's really hot, too. You can see, oh, hot. There's our container. It's so hot I can't really touch it. But it's almost empty because all of that stuff foamed up and out from that container. Oh, one perfect bubble right on top. Can you guys see that? Yeah, it's getting bigger and bigger. Right here, maybe that'll help. Yeah, that helps. Anyways, so does anybody have any questions about that? Okay. If you do, feel free to ask. We will be doing this again next week, but the time is changing to 3 o'clock instead of 3:30. So, be here an extra half hour early. Tell your friends. We'd love to have you. Why did it react? Great question. So, it reacted by the potassium iodide. It acts as what's called a catalyst, which means it needs a small amount for a big reaction. So it acts as a catalyst to release all of that oxygen that's bound up into hydrogen peroxide. And when that oxygen is released, it happens really fast. And because it happens so fast, we get that upwards force that pushes all of that foam out, and we trap all of that extra oxygen inside the bubbles of the soap. So that's why it happened like that. You can see I got a little bit of it on my arm, and it turned me a little bit orange. That's because we were dealing with the iodine. Remember, when it goes from iodide to iodine, iodine is orange-brown. So one thing we could do is take a little bit of our starch and that we were dealing with before and combine it with this stuff, and it would turn bluish black. In fact, why don't we try that, because that sounds really cool. I love science too. Okay, I'm gonna hold our close-up cam right over here. Hopefully, I've never tested this before. Hopefully this works. You can see it's, yeah, there it is working. You can see it gets like darker colors. Like it's not just staying white, it's turning kind of brownish bluish purple. That's because the iodine is reacting with the starch. Just like our other experiment. So next week, I think we're going to be looking at fire, because fire is fun, and I'm going to try to not set my house on fire. But we have a lot of cool experiments to do with fire. I'm going to need to think of some stuff that you can maybe do at home with some help. And we're going to talk about oxygen and carbon dioxide and other stuff like that. So there's some really cool stuff coming up. Take a look at the Google Classrooms in order to sign up for more programs and to see what you're going to need for this next week. Llamas, Spanish for flames. Now I know. Awesome. Thank you so much, everybody. I hope you have a great weekend, and I hope to see you again next week for some more really fun, cool science stuff. Bye. Have a great day.